recording in progress. Almost forgot to record. Okay. 华语课 later 2 to 4 p.m. Later come see me. Don't. Please don't come. You old senior don't come, okay? Okay, almost become goldfish memory. Yeah lah. Okay, so guys, this is like actual exam paper. Okay, I mean not for every schools lah. So what we can see here is the SMK Seri Kembangan. Okay, I don't know whether anyone from there, but I don't think so lah. So this is the I would say more or less similar format because your first exam usually your teacher say no paper 3, kind of don't have kertas 3, no, don't have amali. And then what they're gonna do is they're gonna combine paper 1 and paper 2 into one paper. Of course, if your timetable out already, they say paper 1, paper 2 like separate, of course, they're gonna do full format lah. Okay, so this one is like a simple go through on what we can see. Okay, let's say for here, is what they do is they combine paper 1, paper 2. Okay, but so that this format is actually not the actual format lah. So that is like the school teacher they self do one. They never follow the actual SPM format. So what they usually do is, they will give you like objective. This one I'm just gonna skip objective. So what you can see, if I go straight to section B, okay, usually your exam paper will the hardest part is here lah. Okay, so you see, like guys, you see first question, what they're gonna ask you is it heating curve. Okay, they will ask you the type of particles. Okay, why temperature remain unchanged. Okay, so when all the chemical turn from solid to liquid, state the observation. So guys, so if you're wondering, teacher, are we doing like exam questions? Because you say, teacher, some students say, teacher, your TTC notes the exercise is it I see exam paper and TTC exercise are a bit different. Okay, guys, actually what we do is we just take from exam paper. Okay, so really what we are doing is really exam paper one. So you got the proton number, got nucleon number, okay, and then they can give you unknown Z. Okay, they ask you to write the ion. Okay, so these are the tricky part lah. They give you an atom, but they ask you to write the formula of the ion. Ion means got extra positive charge or extra negative charge. Okay, so this is the idea of it. And then they ask you to state the group. Okay, we just learned this literally last week, right? We learned group, we learned period. Okay, so this one is actually the possible question. And then right, guys, equation. So I believe equation is where you all struggle a lot. Okay, need to be careful on equation. So equation, a lot of question to ask on. Okay, and then of course, maybe they give you some weird drawings. Like you see, like, oh, teacher, what is this? Wow, so complicated. Okay, and this is actually plastic. It's a raw material, okay, to make plastic, and the actual name is called benzene. Okay, so teacher, I don't know what is this. But guys, even if you don't know what is this, you will be asked question that you know. Okay, for example, let's say assume that you really don't know what is this. Okay, because you already don't know. State the meaning of empirical formula. Have you learned before the definition of empirical formula? Got ma? Then you see, why write empirical formula of benzene? Guys, what's empirical formula? Means you go and count the how many C, how many H, then you simplify it because that is the definition of empirical formula. You find the simplest whole number ratio. So and then you see they give you some weird chemicals, C6H plus Cl2. What happened here, guys? Don't worry, because they already give you the equation. They ask you that, they give you like number of mole, calculate volume. Guys, what is this? Number of mole calculation. Even though the chemical here is given that something you don't know, but equation given, then numbers given, molar volume given, all you do is just apply formula. Okay, so it's only 2 marks. Okay, it looks very complicated, but only worth 2 marks, guys, because it's really very easy. So you don't get scared by like weird symbols, okay, maybe like weird equations. Okay, you just focus on what they need in the question, and then you just apply what you learn. Okay, now of course you see go your equation, and then you can see like write all the particles. Okay, isotope. Guys, remember isotope? Same something, different something. This one you have to write later on. You have to write a lot of times. Okay, and then you see like right electron arrangement. Also, we learned this in chapter 2. Okay, what is valence electron? And then you see, guys, remember this? The open and closed experiment of magnesium oxide. Then they're gonna ask you to calculate the mass, calculate empirical formula, do the table. Okay, and then you see, and then of course we got copper oxide experiment also got, because guys, remember empirical formula, we got 2 experiments. One is the magnesium oxide, the open and closed. Then the copper oxide one is this one, no? Okay, remember the the two test tube one, okay. So this one is actually what we're gonna do later also. I see also write chemical equation, also write observation. Okay. Then you see then the next question you see periodic table. What's the meaning of period? Guys, what's period? The horizontal row. Okay. What is the group? The vertical column. Okay. So this is later on what we're gonna write lah. Okay. And what is the basic principle used to arrange element in table? Guys, what I told you last week. How do we arrange elements in your periodic table? It's based on increasing proton number. Okay, so H is 1 proton, helium 2 proton, okay, lithium 3 proton. So based on increasing proton number. So this are, see, guys, all these are possible exam question. No? Say, my teacher, what if I have we're gonna have essay. How to write essay? This is where we're gonna see something like this. Okay, let's say if I flip to say bagian C, bagian B and bagian C might be an essay. Okay, so they describe the subatomic particle. What is subatomic particle? Proton, how many electron, how many neutron, how many this other stuff. And then write the electron arrangement. Okay, use the electron arrangement, determine the position. Guys, what's position? How many, what is the group? What is the period? Okay, now, and then explain. Then of course, then they give you like C, they briefly describe the observation and chemical equation of the reaction between X and water, X and oxygen, X and chlorine. This one is actually chapter 4, where we actually haven't learned, because if you see element X is this one is actually group 1. So group 1 element, if you react with oxygen, water, and chlorine, they will have observation, they will have equation, where you're gonna see this is 11 marks. Okay, not. So guys, don't treat essay into something very complicated or very disgusting. Okay, you have to actually understand that essay is just another form of question where they combine many things in one question. Okay, now instead of like giving you like 1 mark, 2 mark, 1 mark, 2 mark, they ask you one whole question. Okay, then they ask you, they give you more marks. Okay, now. So literally just ask you for observation, ask you for equation, which is something you supposed to also write in the previous question. You see, even in bagian B, bagian A, you also do quite observation. You also write like equation. You done this before. Just that now become essay, then you don't know how to do. Impossible, so you're supposed to still know how to do. Just that you all might be confused, like, oh teacher, 11 marks, how to get? You get scared by the marks. 11 marks, don't know where to get. Actually, it's the same one. Okay, you just follow what they want. They want observation, give them observation. You see, they have 3 experiment, you give three observation. You have 3 experiment, you have 3 equation. A lot of marks already. Okay, so guys, this is a sample of exam paper where maybe if you all don't know what you're supposed to expect for the coming exam. This is what you are expecting. Okay, something like this lah. Okay, not necessarily exactly the same format, because this one is teacher do one. Teacher combine paper 1, paper 2 together. But if your school exam paper 1 and 2 is separate, then they'll do the actual format lah. But more or less it's the same. Okay, so guys, why am I showing you exam paper? Because I want you guys to understand. Okay, next time you see question like this, don't scared. Okay, you done this before. Okay, you done this here in seminar, you done this here in our normal classes. Okay, so guys, let's try to go back to our seminar material. Guys, so see for here, guys, today my main point, because we only have 2 hours, okay. So the 2 hours here, I mainly want to do a lot of exercise. So there are notes provided. Okay, there are notes and short questions provided. Okay, the heating curve, cooling curve, the subatomic particles, okay, and then you can see like the proton, neutron, and then of course we have isotope, definition for isotopes, and then we have calculation for isotope. Guys, remember? Okay, we call this the natural abundance. Okay, to calculate like, in nature we got how many type of the same element, but they got different number of neutron, so they will actually have different percentage. Then we can calculate the average of them. So this is what happened now. And then also we got radioactive isotopes. So this one low chance a bit, but you kind of need to memorize like who is giving you what radiation, this and that lah. And then of course going down, okay, you see examples, and then you guys calculation comes into play. Remember the 3 formulas we learned here? Okay, mass over molar mass, volume over molar volume, okay, this and that. Okay, and then of course guys, the experiment. Okay, and for empirical formula, you have magnesium oxide. You have a second one called the copper 2 oxide experiment. Later we do a lot of this one. Okay, and then also we have the discussion of the question and the possible things they will ask. Okay, so guys, these are the things that we're gonna cover for today lah. Okay, for the seminar here lah. Is you treat this as a basic revision. So I never cover chapter 4 because chapter 4 we are still learning in our class lah. Okay, so what we do here, guys, I will not go to the notes anymore. Okay, what we do is we do question, and then if anything you're not sure, you ask. Okay, if anything I want to refer to the notes, I'll refer to the notes and let you know where I get an answer from. Okay, so we straight do exercise. Okay, we learn from exercise is the most efficient way. So if a lot of students ask me, teacher, what is the best way to learn chemistry? Guys, I will say, you practice more exercise. Okay, you say, teacher, what if I see question I don't know what to do? Never mind, you read the answer. Okay, our question always come with answers. So you read the answer, you understand the answer, then you can force yourself to do more question with a similar way of asking. Okay, so practice more is the key. Okay, so if you go down, guys, we should take page number 12 onwards. It's our question now. So we have actually for this notes, for this material, we have 9 type of questions, 9 common type of questions. So see like question 1A, and then if you flip next page, is question 1B. Okay, and then you flip again, got question 1C. So question 1 is a type. Okay, so the number is a type of question. So if you flip at the back, you flip got like question like 2C, then if you flip got question 3, question 4, question 5. Okay, so basically you have question 1 to question 9. But question 1 to 9, every question I also give you multiple choices of question. Means question 1, we give you like 4 questions. Then question 2, also give you got A, B, C, D. Question 3 got A, B, C, D. Question 4 got A, B, C, D. Okay, so means each question got around 3 to 4 questions. So you got 9 types, so 9 times 4, okay, you get around like 30 to 40 questions. Okay, so this is what we actually included in this material lah. But my one got answer lah. You want no answer for now. So what we do here is I will do whatever I can do. If those I cannot finish, I'll give you the answer. Okay, so let me see. Okay, so guys, let's straight away go for page number 12. Okay, this one straight away go for exercise. So we are given with different element. We have RSTU. RSTU. So okay, guys, before I start, must remember what is the number. What does this number stands for? So the smaller number is always the number of proton, while the bigger number is always the number of nucleon. Okay, so I must know. Nucleon means what? Nucleon means proton plus neutron. Okay, proton plus neutron. Okay, so now what is meant by proton and nucleon number? Guys, literally the definition. So what is, okay, so let me go for the simple one first. Proton means what, guys? I believe a lot of you guys are teacher. Proton is proton. Proton. What you want me to say? Proton is proton. Guys, I know it feels a bit weird to ask you what is a proton. Okay, so the definition for proton, you have to include, say, it's a number of proton, but the actual thing to actually mark you whether right or wrong is the thing after the number of proton. You have to say number of proton in the nucleus of an atom. Okay, you must end your sentence with in the nucleus of an atom. Okay, then same thing go for nucleon. Teacher, nucleon is what? Nucleon, okay, nucleon at least got something to say. Nucleon we say is proton and neutron. So it's the total number of proton and neutron. But guys, same ending. Ending must be the same. You must end with in the nucleus of an atom. So you can see the word here. So the proton number is the number of proton in the nucleus of an atom, while nucleon number is the total number of proton and neutron in the nucleus of an atom. So do you see the keyword is here? In the nucleus of an atom. So no matter you're explaining proton or nucleon, your ending must end with in the nucleus of an atom, because proton and nucleon, the stuff is all inside the nucleus. Okay, so that is actually that is why we actually do this. Okay, good. Okay, and then state the number of electrons in atom T. Okay, so guys, T got 39 nucleon, got 19 proton. But did they actually give you electron? But guys, as we know, electron same as proton. So he got 19, then he also got 19 electron. Okay. How to find number of neutron? You take the nucleon minus the proton. So 39 minus 19, you shall get 20. Okay, then define isotopes. Guys, what is isotope? That is a full definition for you to memorize. You must follow word to word exactly word to word because uh I've been very disappointed with school teacher right now because school teacher cannot accept similar answer. They must accept exact answer based on marking scheme. So guys, I have no choice to force you all to tell you all that you need to memorize the full definition word to word, word by word of isotope of everything lah. Okay, anything they ask you about definition you must memorize word to word. So what's isotope? So we all know what isotope you all say is what same something something different something something so same what same number of proton but different number of neutron. Okay, proton same, neutron different correct or not? Okay, but then you must not stop there. What do we say? Is you have to say that same number of proton but different number of neutron? Not yet. The ending of it must include of in the nucleus of an atom. No, not anymore. Okay, because because definition of isotope you must say is for that specific element lah. So we can say that that's full definition So wait here. Okay, we have to say that atoms of the same element. You must actually say this. Okay, they are the same element with the same number of proton but different number of neutron. Okay, so guys, do you see I put a slash there? The slash there you choose. Okay, but I will always prefer to choose number of proton and number of neutron. Okay, I don't know why. I just feel like this thing a bit more suitable for me lah. Okay, so you choose the one that is suitable. Okay, you say, teacher, if I go with same proton number can can, but you must pair with say a different nucleon number. Okay, yeah, teacher choose the long one. I don't know I like long stuff. Hey, sorry. Sorry. Okay. Sorry, early in the morning Okay, cannot control myself. Okay. Question mark. Okay, so this is the definition for isotope. Okay, you must include the word atoms of the same element. They are the same element, but with something similar, but something different. Okay, so this will be the stuff that I have to include. Okay, and which pair are isotopes? So guys, you see, so same proton, different neutron. Right, so we say that it's S and U lah. Explain your answer. So by the same definition we say that just now, S and U because they got same number of proton but different number of neutron. So for my answer here, I go with same proton number, different neutron number is also fine. Okay. Can so you all take your time to write Okay, guys, write slightly faster lah. I want to cover more questions today. Okay. State two different physical property between two isotopes. Okay, so guys, what's physical property? Physical property there usually they will involve some measurable content, such as what? Such as melting boiling point, maybe density. Okay, this and then whether it able to conduct electricity or not, like electrical conductivity, heat conductivity. So a lot of stuff that we can actually do like measurements. So we call them physical property. Okay, there's another property called chemical property. Chemical property is where we involve chemical reaction. Okay, we try to burn with oxygen, try to dissolve it in water. So all this is what we can say is the one is called the chemical property lah. But for physical property, very simple, it's affected by the total mass of the atom. Okay, so where the total mass of the atom is the 12 and 14. So nuclear number is literally the mass number. Okay, the molar mass, okay, to be exact, the word, if you all remember, molar mass of the atom. So if got 12 and 14, obviously you got heavier concept. Okay, so 14 so he's a bigger number. He's supposed to be higher density, this and that lah. So we have multiple answers. So we can say that higher boiling point, higher melting boiling point, and then higher density, higher atomic mass. So these are the physical property that we can choose from. So I'll always prefer density. This is the easiest one to memorize. Then melting boiling point, also okay. Okay, you can say lower melting and boiling point or higher melting and boiling point also can. Okay, and then will the two isotopes react the same way? So need to write high, lower or higher. I mean for here actually they just want melting point, boiling point, and density. Okay, then no need to write who higher, who lower. Because they only want to choose the state, the different physical properties. So they got different melting point, they got different density. Okay, will the two isotopes react the same way, guys? When I ask you react the same way, it's literally asking you the chemical properties. Okay, so how do they react? They will always react the same way. Why? Because they got different physical property, guys. They always go in opposite one. So if something got different physical property, then you always go with similar chemical property. But actually, there's a reason for that. Okay, why got similar chemical property? Chemical property is based on what? Actually, the ultimate word to say is based on valence electron. Why do I say based on valence electron? Because you see okay, you see so the S here, you got 6 electron 6 electron So if you actually write out the electron arrangement, it's 2.4 and 2.4. So because of the last number is the same, they react the same. Okay. Because if I give you like, remember last week I teach you group 18. If you got 2.8, any reaction? No. If got 2.1, got reaction? Got 2.7, got reaction not? Got. But actually those who have reaction the 1, the 7, and the 4, they react differently. Okay. But if you have same valence electron, they react the same way. Okay. So we can say that. Okay. We can say yes because both isotopes have same number of valence electron. So we can say that they have same chemical properties. Okay, and then of course we have to memorize of a few isotopes lah. So in medical field, so we can go with cobalt 60, agriculture we can go with phosphorus 32, archaeological we can go with carbon 14, industrial area there's a multiple of it lah. So I will go with sodium 24. Okay, so guys for here it's just purely memorization lah. So try to memorize them. Okay, and then of course what is the medical field cobalt 60 for? Usually for killing cancer cell. For phosphorus 32 will be your study of your fertilizer intake. And then for archaeological is to estimate the age of your fossil. And then sodium 24 is to detect leakage in your gas piping. Okay, so these are the few things you can say lah. Kill cancer cell, study absorption of fertilizer by plants, okay, estimate age of fossils, detect leaks in pipes. Okay, so these are guys, try to write down and force yourself to memorize a little bit. Okay, give you guys like a 1 minute to write this. Okay, moving on. Okay, now we have substance PQR, we have different melting and boiling point, suggest the physical state at room temperature. So this one, a lot of people also try to, because this question also very common in your first exam, they always love to ask this type of question. So my way of doing this is first understand, guys, what is room temperature? Room temperature is actually at a fixed temperature at around 27 degrees Celsius. Okay, 27. So you try to remember room temperature is 27. I know whether nowadays in Malaysia a bit hot, okay, the room temperature in Malaysia not 27. Okay, but in science lab, okay, room temperature is 27. So in 27 right here, how are you gonna understand that? Is it solid? Because they ask for physical state, physical state means solid, liquid, or gas. So how to find solid, liquid, or gas? Okay, you have to understand like this. If the temperature is more than melting point, then it's melted, no? Means it's liquid, nah. But if before melting point, it's solid, no? Then same thing goes for boiling point. More than boiling point is gas, less than boiling point is liquid. Okay. So the idea is you try to imagine you go from left to right. Before melting point is solid. After melting point, but before boiling point is liquid. After boiling point is gas. Correct. So try to take this 27, 27. So I try to move it around. Okay. Is 27 more than negative 183? Yes. Okay, is 27 more than negative 89? Yes. So this will be here, no? Okay, now so 27 is more than both of them. So P is a guess. Okay. And then Q, same thing. Is 27 more than 15? Yes. More than 17? No. So 27 stays here. So at Q at 27 degrees Celsius is under liquid condition. Then for R, is it more than 900? No. So he stays as solid. Okay, now. So from here we know that P is gas, Q is liquid, R is solid. So for here we can say, okay, gas, liquid, solid. Okay, so try to move around like what I did. Okay, then we have your boron exists naturally as two isotopes, 19.9% of boron 10 and 18.1% of boron 11. Calculate the relative atomic mass. Guys, when I give you something like this, they give you like different percentage of the same element, you're going to calculate the average of it. So how do you calculate the average of it? Very simple. So we can say that, okay, so the relative atomic mass will be, you take percentage multiply the molar mass, percentage multiply molar mass. So you shall get 19.9 multiply 10 plus, okay, 18.1 multiply 11. Then you whole thing divide 100. Okay. That's how you calculate average. Percentage multiply mass plus together divide 100. Okay. So you press a calculator. 19, wait, 80.1 times 11 plus divide 100. So you get 2.19. How you get 2.19? You type wrong. Okay, recalculate. Okay, see, so if you do the maths, okay, this one is 199, this one is 800 plus, okay. So total out you get like 1,000 plus. And you divide 100, you get 10.801. Okay, if not mistaken. But of course, you can just give me 10.8, it's fine also. Is it 10.8? I don't know. Later I press some calculator also. Oh, you type wrong, so my answer correct. Okay, good. Okay, so this is the basic way of doing like calculation for relative atomic mass. But what if they give you a different calculation, which is the reverse calculation of your relative atomic mass? Okay, how you do this? I say they say sulfur got two isotopes, 34 and 32 lah. Okay, 32, 34. It shows that the relative atomic mass of sulfur is 32.1. It means the average of these two is 32.1. So what is the abundance of both of the isotopes? So this one, you have to do a slightly more calculation. Okay, but you can use the same formula. What's the formula? Relative atomic mass equals to percentage multiply mass divide 100, right? But now you're already given with the relative atomic mass. So what I can say is 32.1, which is the relative atomic mass, okay, equals to percentage multiply mass. But do you have percentage of both of them? You don't have. So what if I say I set an unknown first? Percentage for sulfur is A. percentage for sulfur is B. Okay, for sulfur 32 is A lah. Then for sulfur 34 is B. So this A and B will be different percentage. Can be the same, can be different lah. We don't know yet, right? So this treat it as percentage. You take A multiply 32, you take B multiply 34, plus together. So I'll be having A multiply 32 plus B multiply 34 divide 100. So what can you do first, guys? Move your 100 over. You're going to get 3210, 0. And then you get 32A plus 34B. Correct not? But of course, guys, you're going to start here. Why you start here? Because your A and B is two unknown. Can you find two unknown using one equation? By your understanding of simultaneous equation in maths, cannot mark, right? So what you're going to do? You're going to try to think about another formula when it relates A and B. So I told you A is a percentage of 32. B is a percentage of 34. So if both of them is percentage, what is the total percentage if I plus them together? So I believe it will be 100%. Yes, so I can say A plus B equals to 100. So I move either my A or B, either you choose one lah. I'll be moving, let's say if I move my B over, I get 100 minus B. Then you substitute your A. You do simultaneous equation. Literally, you do maths, okay? You put in your A equals to 100 minus B. So you're going to get something like this. So 32 multiply 100 minus B plus 34B. Then you get this number. Okay, expand the equation. So 3200. Guys, I think it's 3210, right? Not 00. Okay. I think too much, guys. I think too much. Okay. 3210. Okay, not 32,000. My bad. Thanks, Isaac. It means that Isaac is focusing. Good job. Okay, Isaac, I give you a kiss on Tuesday. Okay. Isaac be like, Okay, so yeah. So of course you put in your 3200 and then minus 32B plus 34B equals to 3210. Okay. And then what you're gonna do is you do the maths, you plus, okay, you plus the one with B, then the one without B you throw over. You 3200 you throw to the left. You take the 3210 minus the 3200, you'll be left with 10. So 10 equals to 2B. Okay, am I going too fast? Am I going too fast on this step to this step? Hopefully your maths is good. I don't have to worry about your maths. Good. Okay, so you can finally find that B is actually 10 over 2. You throw your 2 over, 10 divided 2, it will be 5. So B is actually 5%. Okay not? Okay, maybe maybe don't have to worry about maths. Okay, so then your A will be 100 minus 5. A will be 95%. Okay not? So you're gonna try to tell the teacher. So percentage of sulfur 32, or you can like this, sulfur 32 is 95%. Then percentage of sulfur 34, it will be 5%. Okay, guys, hopefully this one question covers a lot of stuff in chapter 2. Okay, but guys, of course, I have other questions more lah. So I will do one type of each question. So I do one A already. So B, C, D, you do yourself. Okay, question 1, B, C, D, you do yourself. They are similar questions. Okay, so what you do is, after I done question 1, okay, you do B, C, D. Okay, I straight away go for question 2A. Okay, I go for another type of question. Okay, so this one will be page number 60. After calculation, after your isotopes, okay, we're gonna go for the heating and cooling curve, but still under chapter 2, but a different way, different type of questions lah. So we can see that this is actually the experiment where we heat up your chemical called naphthalene, and it will actually melt, and we try to find out what temperature he melt. So they ask you, why is a water bath used in the experiment? So guys, what is water bath? So as we said that, if you heat the naphthalene directly, your naphthalene will never get the heat in an even way. Okay, why? Because the bottom part will get heat up first. then the bottom part melt first. This is not what you want. It's unfair. So what I want is I want the whole thing to get the heat evenly and melt at the same time. So water bath help you to do that. So what we can say, number one, you can actually ensure even heating. But do you see it's 2 mark? Ensure even heating is only 1 mark. So what is another possible answer? It's actually about the naphthalene is actually flammable. If you heat without water bath, what if the naphthalene suddenly like spill out and then your fire touch the naphthalene? Congratulations, okay, you burn down your school. So from here we can say that, okay, we can say that water bath, okay, so to ensure heating is uniform, or you can say heating is even, okay, up to you, choose either one of this. Then we can say naphthalene is flammable. So these are the 2 marks we can see from here. Okay. And what is the purpose of stirring S with thermometer throughout the heating process from room temperature to 90? That's stirring, same thing lah. Why you want to stir? Because if you don't stir, inside, outside, outside get the heat, inside get the heat later. So you want to stir so that you can get the heat is even again. So the outside and inside they will change their position. So the outside of this means the chemical outside, and the inside they actually melt in different timing. So to ensure to reduce this error, we try to stir them. Okay, so this is what we can say from here. To ensure the heating is uniform, the temperature is uniform. You can use the word uniform, you can use the word even, it's fine. Okay. If substance S is replaced with Q that has melting point on 109, is water bath suitable to be used in the experiment? So guys, as we said, this experiment is doable because of naphthalene melting point around like around 80 degrees Celsius okay, around there. So water definitely is able to heat until 80 But for now, if I change to Q melt at 109. Can water achieve 109 temperature? Cannot. Because water at 100, what happened? He boil. He fly away. Correct or not? So if he fly away, can he reach 109? The answer is no. So you have to say that the melting point of Q is higher than the boiling point of water. Okay, so this is what we can see. So melting point of Q, okay, so with first thing we say no lah. Okay, they ask you, is it suitable Then they ask you to explain. But guys, I think this 2 mark is wrong lah. Okay, it's a 1 mark only. Okay, writing no get 2 mark. You all think too much. Okay, so what is the explanation for why you say no? So we say that boiling point of water is 100 degrees Celsius. So the melting point of Q is higher than the boiling point of water. So sad, 1 mark only. Hey, you write NO, 2 alphabet, you get 1 mark. Very kind already, okay? Don't sad. 2 alphabet get you 1 mark. Okay, and then again they say that the natural abundance of I thought explanation together. Oh no lah, I also thought explanation together, but I seems like number 4 is explanation. But turns out it's separate question. It's fine. They can combine, they can separate, up to them. Okay, so we have copper 63. The abundance is 69.17%. Then the other one, copper 65, is 30.83%. Calculate the relative atomic mass. Okay, guys, I think this one we done this just now already so it should be very easy. So the relative atomic mass will be percentage multiply mass plus percentage multiply mass over 100. Okay, you all do the maths again. Okay, so if not okay, guys, what you calculated out, you shall get 63.62. Hopefully you all got this. Okay, and then guys, there is another similar calculation where they give you the isotope relative atomic mass. They ask you to calculate percentage of the 203 and 205. So guys, this one is similar question that you see just now. So I would like to skip this thing, okay, because I want to do other questions lah. This one you just you apply the simultaneous equation method. Okay, so the B2 I leave it to you. Okay, let's see how many proton and electrons are there in lithium ion. Okay, so this is the one of the tricky question you might see in exam. So first of all, they ask you lithium, and then they give you lithium proton is actually 3. Then they ask you how many proton. You be like, teacher, they ask me how many proton. Then they give me proton. Isn't it you feel like, teacher, isn't this the answer? Yes, the answer, one of the answer is yes, proton number is 3. Okay, but how many electron? By right, a normal atom, how many proton means how many electron, right? So if he got 3 proton, he means he also got 3 electron. But there is a hint here. They said that this is lithium ion. What is ion? It means it has charge. It has charge means that the electron is no longer the same number. Means that electron just now was 3, originally is 3 on again. But what happened to this ion? Do you see there is a positive charge? So let me ask you one question. Yeah. Okay. What is the charge of proton and what's the charge of electron? If in your mind, I will say that you know that proton is positive charge. Okay, proton is positive charge, and then electron is what charge? Electron is negative, correct not? So if he got 3 proton and 3 electron, by right the atom is like neutral, no charge at all. But now, if you want to go into Li plus, Chan Chen gave me the perfect answer. If you want Li plus, what do you do? Okay, let me give you 2 choices. To get plus, right? Yeah, there are 2 possible things to do. You can either go with teacher, can I go with like 4 plus and 3 minus? I increase proton. Or maybe I can maybe decrease the electron, means proton remain, then electron lesser. So I reduce electron. Because like this, you get difference by a positive charge. Like this, also you get a difference by positive charge, right? So either way, the difference is by 1 positive charge. It fulfills the Li plus, correct? But got one is wrong, which is the increasing proton is wrong. Because can you increase proton number? No. Proton number is it's like IC, okay? It's like IC of every element. They have fixed proton. Why fixed proton? Because where is proton actually? Inside the nucleus. So is it possible to modify something inside the nucleus? No. But what we can do? Modify the electron. Electron outside okay, orbiting the nucleus, right? So orbiting, he can anytime leave the orbit, kind of. So what you can do is to reduce the electron. So guys, in exam, if you see anything with charge and they ask you proton, electron, you only think about the electron changes. Don't change your proton, okay? Don't go and plus increase proton or decrease proton, okay? You can only increase electron and decrease electron, okay? You can only modify electron. So the answer here is proton remain 3, but electron now is decreased to 2. Okay, can all good, should be fine. Okay, going down. Okay, this one is heating curve. Let me do one question of this. We have melting point, boiling point of methane is -182 and -162 respectively. He plotted a heating curve of methane. Label X and Y. So guys, -182 and -162, who shall be X, who shall be Y? This one is a tricky question also, because by giving you a positive number, I think it's very normal for you guys, but I give you a negative temperature. So X is higher, Y is lower, but -182 and -162, who is bigger, who is smaller? Hey, okay, don't say 182 bigger, guys. But if it's -182, it shall be smaller. Okay, can so -182, 162 is bigger, -182 is smaller. Okay, so X shall be your -162, then your Y shall be your -182. So we can say that X is 162, Y is 182. And because they say that this is melting and boiling point, definitely you must melt first, only you boil. So I will say here is melting point, then here is boiling point. Okay, the bottom one melting, the top one is boiling. Okay, state the physical state, which is why I want to say where is melting, where is boiling. Okay, guys, yeah, PQ is the state, is the stage before the melting point, right? So before melting is what physical state. So physical state of what? Solid, liquid, or gas, right? So PQ before melting, before melt must be solid, no? Okay, now. But during R and S, okay, what's R and S or R and S here? Okay, R and S, guys, let me give you an idea first. Still, PQ is solid, but when you hit Q, is where the process start to melt. So within Q and R, is it fully melted? Not yet. It's halfway the melting. So if halfway melting is solid and liquid. Then when it reaches R to S is not melting, it's not boiling, but its temperature increase, so it's actually liquid. Liquid, you heat on supply temperature, supply heat, then he hit the boiling point, then you'll be liquid, boiling become gas. Then T to U is fully boiled, will be gas. No? Okay, now, so RS is liquid, ST is liquid and gas. Okay, so for here, liquid and gas. Okay, RS will be liquid, ST will be mixture of liquid and gas. Okay, that describe in terms of the motion and distance, the behavior of methane gas at TU. Okay, TU is gas, right? Gas is how they move. So gas particles very far apart and random motion. Okay, so that will be the distance, very far apart, pretty particles lah, and then they move very fast, okay, in a random motion. So we can say that particles are very far apart from each other and move freely and randomly. Okay, Isaac asks, can I just write liquid and gas instead of writing mixture of liquid and gas? Okay, Isaac, I will strongly suggest include the word mixture because there is one case last year, not your school, other school. The teacher said no mixture, consider wrong. So I will strongly suggest, okay, write the word mixture. Even though your school is not so strict, but I will say it's not, it will be safe, it will be safer if you use the word mixture lah. Okay, moving on. Draw the arrangement of the methane at -182. Guys, -182 is the boiling, okay? So boiling, so you're supposed to draw a gas particle. Okay, but all is liquid and gas, So your drawing have to half. Okay, a bit liquid, a bit gas. Okay, so you see my drawing, a bit liquid, a bit gas. Oh, sorry. Oh, guys, 182 is melting. My bad. Okay, 182 is melting. So 182 is melting. So it's solid and liquid. So half solid, half liquid. So this one must be half solid, half liquid. Sorry, I see wrong. Okay, explain why temperature of methane remain constant from Q to R. So this is one of the very common question in your coming exam. I can guarantee you either heating curve or cooling curve, they must always ask you why temperature constant. Okay, so for heating, it will be easier one. So why during heating, here is constant, here is constant. Why during change of state, the temperature is constant? So I told you before, the heat that we supply only can do one job at a time. Okay, so during PQ, RS, and TU, okay, during these three stages, the heat you supply is to increase temperature. That is the job that they are doing before they hit the melting point and before they hit the boiling point. Okay, but what if they really hit the melting point, which is QR, and also the boiling point, the ST? No matter which one they hit, the heat that you supply is not used to increase temperature, it's used to change the state. How do you change the state? Where let's say for here to see the diagram, solid state, they were very near, correct? They were having very strong, they are having like bonds in between them, they have like forces between them because they are in solid state. So what we do is the heat you supply come in and break their bond. Okay, they were like side by side holding hands. Your heat come in, don't hold hands. Start moving away. So this is what the heat energy do during melting and boiling process. Okay, so what we can see, so if we say that the heat you supply, you still supplying heat, your heat is never away, your heat is always at the bottom in the Bunsen burner, is heating up the chemical. So the heat is always there, but you have to mention, is used to do something else. So we can say that, so heat energy absorbed is used to overcome the forces of attraction. This is the word that you must use. Cannot say break the bond, because break the bond is what I said just now. I give you a simple idea on break the bond, but cannot write break the bond, must write overcome force of attraction between particles so that solid turn into a liquid. So that is what happens when a temperature is constant during a heating curve. Okay, and then after heating, the next question it will be cooling off. So we cool down on naphthalene. So if you cool down on naphthalene, they ask you what is meant by freezing point. So when they ask you all these point, different point, freezing point, melting point, boiling point, what's point? Point is the temperature. And freezing point is the temperature where he freeze. But don't say so easy lah. The temperature when he freeze is what state to what state. So freezing is liquid state become solid state. So you can say that it's a constant temperature which liquid changes to solid at a specific pressure. Okay, must include the word at specific pressure. Why specific pressure? Okay, because if you don't say specific pressure, actually pressure do affect your melting and boiling point and also your freezing point. If you try to freeze your water at a different pressure, let's say you have a specific room or a sealed container, that the container apply like stronger pressure compared to what we have in daily life, you will actually make your freezing freeze faster. You freeze at lower temperature. So pressure actually indirectly affect every point that we have. So that's why in our definition, we always say state at a specific pressure. Okay, because right now the pressure around us is 1 atm. Okay, if you do your heating, melting, boiling, okay, in a different pressure, it will be different. But of course, you won't get to do that lah. You wouldn't actually have the experience to do heating, cooling at another pressure, because to change pressure is something very hard to do. You can't do it in school. Okay, but what you're doing here is in atmospheric pressure. That's why we call this fixed and specific pressure, because all the pressure we are having right now is atmospheric pressure, 1 atm. Okay, explain why temperature remain during freezing. Okay, this is the opposite of heating. Why heating curve go up, like then we say is overcome, energy absorbed is overcome, is to overcome the force of attraction. Okay, then we can say that why temperature remain during freezing. So same thing, cooling down also got like constant temperature, but the explanation will be different. But something you can go with, You can say that just now we say heat energy absorbed is for heat when you supply heat. But now if you're cooling down, heat comes out. So we can say heat energy release. But of course, there are two types of answers to write. You have to understand that during cooling down, heat come out. Okay, the heat energy come out. Correct. But when the heat energy come out, it's supposed to actually decrease your temperature. Make sense? So your graph goes down in the beginning. Makes sense. Okay now. But when during change of state, like let's say if this chemical, this liquid, he really freeze at a certain temperature. He freeze from from liquid to solid. During the liquid to solid, what happened? He again release more energy. But this energy release is supposed to make the surrounding actually increase temperature. Okay, how it works is here. Imagine you have a freezer, okay, and then you have a cup of water, okay. So the freezer, so this freezer here, freezer temperature very cold, correct. So it's supposed to decrease your temperature. Okay, freezer decrease temperature, makes sense, right? But during the water freezing, he actually from moving around, becoming fixed position. So during moving to fixed position, it's like guys, you walking, then you suddenly stop. You got extra energy. You release out the extra energy. So the extra energy will actually come out and make your temperature of your freezer increase. Because extra energy come out, will increase temperature of surrounding. So because of this temperature increase during the freezing process and the cold temperature of your freezer, these two temperature balance off each other. It makes your graph looks as a straight line during the freezing situation. So how do I say in this way? Means that the temperature go down halfway. Got somebody release energy to balance off, become a straight line. So we have to say the answer here is heat loss to surrounding is exactly balanced by heat energy release as the particle attract one another to form a solid. So heat loss to surrounding, this is actually temperature decrease. This is the freezer. Imagine heat loss to surrounding is a freezer. Is balanced by the heat energy release during particles attract one another. This is where I said the particle give out energy. So these two energy balance off each other, they become a straight line. They become a constant temperature. Okay, someone asked, or Jaren asked, right? If I write at right, instead of a specific pressure, I write at atmospheric pressure. It shouldn't be wrong, but since they ask what is a freezing point, freezing point in a general understanding, we say at a specific pressure. Okay, you say at atmospheric pressure, that one is freezing point of naphthalene. Maybe at this experiment I will say it's fine. But this one is marking scheme answer So maybe if you got a chance, you can try to write atmospheric pressure instead of specific pressure. Then you let me know. I will say it's fine. If I were your marking scheme, if I mark your paper, I'll give you correct. Okay, but different teacher, different way of marking. Okay. So if you ask me SPM okay or not, I will say SPM okay. SPM okay one, don't worry. Okay, but your school exam I cannot guarantee because your school teacher a bit hard to give her perfect answer. Okay, then draw a cooling graph. So the graph goes down and then with a constant temperature. So you're supposed to make sure you draw your y-axis, your x-axis, label temperature, label time, and then your graph go down, constant temperature, go down. Okay, so you're gonna see something like this Okay So P, okay, no need to label P, Q, R, S You just go down straight line, constant temperature, and then go down straight line again. So and then label the freezing point. Did they actually give you freezing point? No, right? So even if it didn't give you freezing point, you don't even need to label this. You just draft, okay? PQ, PQ, QR, and RS should be okay. Okay, guys. So done with heating questions. So heating question, I do one already. So this the rest you all try lah. Okay. So maybe you all wondering how this thing this question how can we this in bit essay form? You can flip. Okay, you flip a bit. Page number 19 is the essay way of this question. Okay, let's say if you look at page number 19, will be our question 3, our third type of questions. Okay, so I'll give away 3 different drawings. Obviously, it's solid, liquid, and gas lah. So compare all these in terms of arrangement, movement, attraction forces, and kinetic energy. 12 marks. Guys, have you seen question like this got 12 marks? I believe maybe it's the first time. Okay, but guys, it wouldn't be your last time. Okay, and guys, I would say it's not something very hard to score because you see, when we do comparison, okay, we compare like whenever you see the word compare in a question, you are allowed to answer in table format. Guys, you never hear me wrong. If they ask you the word, if they say the word compare, table format is fine. Okay, no need to write essay, 120 words, okay, 6 paragraph, no need lah. So that you can go with table form and you can get 12 marks very easily. So let's say I write down here first, I got solid, I got liquid, I got gas now. So the first comparison is what? The arrangement. So how do solid particles arrange? If you remember, it's what? Closely packed in orderly arrangement. So you can see, so the first arrangement, we say that solid is close together and in orderly arrangement, orderly manner. How about liquid? Are they close? I would say it's kind of far apart already. Then are they in orderly? No. So we can say that in random manner, or we can say in not orderly arranged. Okay, so further apart, not orderly arranged. While gas is very far apart and random arrangement. So you can say that again is not orderly arranged, but you use the word very far apart. I have to draw this table. Yes, you need to draw this table. Zan, don't lazy. Don't lazy. You early morning come here not to be lazy one, kind of. Okay. In exam must draw lah, guys. If here you lazy, then I cannot do anything also. Okay, then you see, if I use the same idea, how do I go with the movement? How do solid particles move? Can they actually move? Cannot. But then you cannot say they have no movement. All he can do is he cannot flow, he cannot move like far apart, this and that. Okay. But what we can say is this thing, they vibrate. Like you see solid, like you hit solid, you hear vibration, right? This is the vibration of solid particles. So we can say that the movement will be vibrate or rotate at fixed position. While liquid and gas starting to move freely. So you can say constantly move freely, but for gas, I go with move freely at high speed. Do we have to include random movement for liquid and gas? Random? Okay, the word random is basically replaced by here is the not orderly arranged. If you use random arrangement, then it's fine. No need to go with the not orderly. So this is an option. You can say random arrangement. Particles are random arrangement. Are in random arrangement. Optional. Okay, for attraction force, guys, attraction force is based on what? Based on, like you see, guys, how do I know that you are attracted to me, I'm attracted to you? It's the distance between us. If you very near to to your friend, to your crush. So high attraction, strong attraction force. But if you're really far away, the girl that you like at a different school, then the attraction force is slightly weaker. If the girl you like at other country, lagi weak attraction force. Okay, so the strength of attraction is based on the distance between particles. So like solid, very near, side by side, strong attraction. Okay, while liquid getting weaker, gas is the weakest. Okay, so we can go with strong, moderately weak, very weak. Okay. So guys, literally 1 mark, 1 mark, 1 mark. Okay or not? Okay, and kinetic energy is based on how fast he moves. Because kinetic energy, you all learn it from 3, is the energy for something to move around. So do solid particles move a lot? Vibrate at fixed position where can move a lot. So you say the kinetic energy is low. Gas and liquid, I would say liquid slightly higher, then gas is very high. So guys, do you think it's a very hard thing to score? No, right? So guys, as I said, don't hear the word essay, you're triggered. Okay, guys, essay is just a longer question. You put in whatever info you know. Okay, it's just something you know all these things one. Just that you all see essay, you all don't know how to say. Teacher don't know how to write essay. How to write essay, guys. Nothing special. Yes, teacher, it's very hard. You are gonna fail. I said, you fail, I will come and find you, and I will do something to you. Okay. Okay. And I will invite Jaren also. Okay. Invite Zilun, invite Zihan, I'll come. Okay. Do something to you. Jaren be like, no, thank you. Hey, Zilun is not here. See, Zilun only seminar. Zilun only extra class. Zilun say he lazy. Okay. If he lazy, and still can get A, it's fine. I'm okay with lazy students, but if you score, if you have the cards, okay, just like Donald Trump say, if we have no card, you come. If you got your cards, you okay to score A without coming class, it's fine. Okay. Don't worry about it. No cards, people cry first. It's like that one, Donald Trump say already, you have no cards. Okay, explain the state of particles at PQR, and again it's 10 marks. You'll be like, teacher. Okay, first of all, guys, they ask you to explain the state, So first of all, they give you the state, it's solid, solid, and liquid, So P, why is it solid? They say explain, okay, explain. Explain means what? Means that solid. Why is it solid? Because, okay, of course, it haven't hit the melting point. So if it's solid, what is the arrangement? What's the kinetic energy? What's the attraction? What's the movement? All these things. So you can say that. So they can say from here, you see stage P, particle absorb heat energy, kinetic energy increases, it vibrate faster. You see the word I use here? Vibrate. Why? It's a solid. It's not moving. Do we write in point form? Guys, in exam, Don't point. Don't use the point. You just write in sentence, full stop, sentence, full stop, sentence, full stop. You can go in different row. Okay, you can say stage P. Okay, different row. Okay, but don't use the word. Don't point. Okay, don't include the not the pointing. Okay, the numbering don't put in. Okay, just put in the sentence. Okay, so you say, teacher, what if I put in a paragraph? It's fine. You can go in a paragraph. You can just combine all these three sentences in one paragraph. It's okay. But why do I write so many points? Because do you see it's 10 marks and it's three stages ma. So if you like divide averagely, like 3 mark, 3 mark, 4 mark like that, lor. Okay, can Therefore, but okay, by using the same format, how about stage Q? So do particles absorb heat energy? Yes, right? Still absorbing heat energy, but the energy, is it used to increase kinetic energy? So of course, it's used to overcome the force of attraction. Okay. Here, so absorb heat energy still got, but it's not used to increase kinetic energy anymore. Okay. So it's used to overcome the force of attraction, and they will actually become further away. So you can say that absorb energy, heat energy is still there, but you have to include heat energy used to overcome attraction force between particles. So they start to move freely and he start to melt. Again, guys, don't put the point, okay? Okay, and I will say stage R, the liquid stage will be easier lah. Because you can refer to stage P, very similar to stage P ma. But of course, don't use the word vibrate anymore. Here we can say move faster. Same as stage P. You see, exactly same as stage P, and you get marks for writing out the same sentence. Okay, so don't be surprised that you see like 10 marks, 12 marks, okay? It's same. Same. 子伦 say eating more important than my class. It's good student. 子伦 being 子伦. Okay, guys, done with this type of question. Then I can go for another type of question. Finally entering chapter 3, the empirical formula. Okay, teacher, will you post this replay? Yes, I'll post it on YouTube. Okay, I'm moving on already. Okay, now with empirical formula, next kind of question. Okay, you can see something like this. So this is for copper oxide. The other one, for the open and closed one, is for magnesium oxide. So I do one question each. So for here, what is meant by empirical formula? Again, guys, the definition must be word to word. So you have to say that it's a chemical formula that shows you what? The simplest whole number ratio. Don't stop there. Whole number ratio of each element. Sorry. My iPad a bit lag just now. Okay, so you have to say that chemical formula that shows the simplest whole number ratio of atoms for each element in a compound. Okay, how do you dry the hydrogen gas? Okay, guys, because for drying the hydrogen gas, is actually out of this type of question already. For this diagram, no more drying of hydrogen gas. So you can just cancel off this question away. Okay. The notes, the exercise doing, guys, forgot to remove this question. But never mind, guys, just ignore this because no longer you have this in the syllabus. Okay, what is the purpose of using zinc granule and hydrochloric acid? It's actually here. Okay, the right test tube. So it's zinc with hydrochloric acid. The point of doing this experiment, guys, actually the ultimate goal is the copper oxide. I want to use hydrogen to actually take away the O, become copper and water. Okay, means the H2 take the O, and then the O no more already left with copper. But how you get H2 is actually from the zinc and hydrochloric acid. So from here we can say that to produce hydrogen gas, and the equation is almost there already. We can say zinc plus HCl. Okay, you form, okay, the zinc will kick off the H, become ZnCl2, and then your H2 comes out, and then you have the balance equation. Okay, so this is what happened on the zinc and hydrochloric acid. Okay, what change can be seen after oxide of copper is heated strongly? This is one of the observations that you can see. So originally, copper oxide is black. After you heat, it becomes a normal copper. It will be brown. Okay, so this one is brown. Okay, so black solid turns brown. Okay, and then they usually comes with a given result. Okay, for this type of question, they always give you a result So this result, you have to do is what you have to do is calculate copper oxide So you have to calculate the mass of copper individually and the mass of oxide separately. Okay, so how do I find the mass of copper and the mass of oxygen? So for here, we say that okay, this one got copper, this one got oxide So to find the copper, I take the 147.95 minus the first mass. To find the mass of oxygen only, if excluding the copper, you want to actually take the 151 minus the 147. Okay, so for here, I will say something like this. 147.95. Okay, means I will say something like that. So this one, this one, two, this one, three. To find copper is 2 minus 1. To find oxygen is 3 minus 2. Okay, then what are you going to do? Calculate number of mole, guys. So as a recap for calculation, number of mole, we're going to use mass over molar mass. So for mass over molar mass, you shall take the 12.8, divide their own specific molar mass. So one divide 64, the other one divide 16. Then you calculate it out, you get the same number of mole. So if it's the same number of mole, what is the ratio? 1 to 1. And guys, let me give you an idea. Usually these two experiments, the magnesium oxide MgO and the CuO is always 1 to 1. You actually have the answer already in your mind. Okay, 1 to 1. CuO and MgO is always 1 to 1. Okay. So of course, your conclusion will be empirical formula is equal to CuO. And write the balance equation. So we're gonna have, actually I written down just now already lah. So CuO plus H2 is from Cu plus H2O. Why does hydrogen gas need to flow continuously for a while before starting the process? So as we said, this one usually what we know is this gas must be let it flow for around like 5 to 10 minutes. If you don't do that, might causing some possible explosion. Why? Because if you don't do that, there are some oxygen gas here. Then they come incoming the H2. So the O2 and the H2, if you hit like at this moment, you will get explosion. Okay, so for this, basically, you let it flow for 5 minutes, is to let the H2 push out the existing air. So we can say that to remove all the air in the glass tube. Okay, someone asked, is it compulsory to write the states in equation? You mean the physical state? Solid, liquid, gas? No need, no need. No need. No need. SPM, no need. SPM really no need. You see all my equation, no physical state. Okay. If your teacher emphasized that, actually she's not wrong just that she's a bit being too extra. So you can stick to yourself. Okay, stick to mine. Just go with equation. It's fine. No need to write physical state. Okay. What's the difference between balanced chemical equation and chemical equation? No difference. Every chemical equation must balance. They just remind you to balance. Even if they never give you the word balance, they give you write a chemical equation, you still need to balance. This is just the word to remind you that you have to balance equation. Okay. Can empirical formula of magnesium oxide determine by the same method? Means can this method used for MgO? The answer is no. This is why we need two experiments. If MgO can use in this experiment, why we need another experiment? So these two experiments, MgO and CO, these two experiments cannot interchange one. Why? So for here, if you change your CO to MgO, can your H2 react and snatch the O become Mg and H2O? Guys, based on what we learned last time, reactivity cannot, because H2 is less reactive than your magnesium. So if something is less reactive, he cannot snatch his partner. Okay, just like you all cannot snatch my girlfriend, cannot snatch my wife because I'm more handsome. Correct not? So from here, we say that no, because magnesium is more reactive than hydrogen. False, Jared. So what? You say it's a false statement, I handsome than you, false statement, Cannot like that. Okay, it's proven. Okay, proven. I'm more handsome. Okay, next one. False. Okay, the hydrogen gas is allowed to flow until the product of heating is at room temperature. Guys, in this question is basically very similar to F. F is like before you heat, you flow for 5 minutes. Then H is allowed to flow until the product of heating is at room temperature, means you allow to cool down, but the gas is continuing, no stop for 5 minutes even after experiment. So means before experiment, you flow for 5 minutes. After experiment, you flow for another 5 minutes. So why you have to before experiment have to flow, after experiment also have to flow? So before experiment you flow is to remove all the air. But why after experiment you have to flow again? Because the product is copper. If the copper is still hot and then you stop flowing, the oxygen here might come in and react with the hot copper back to copper 2 oxide. So if your chemical is still hot, you just finish experiment, your copper form is still fresh, okay? It's still fresh and hot, okay? Then you stop your H2, is something might be possible that you open up the rubber, then your gas go in, then GG, okay? Your Cu becomes CuO, okay? But your Cu, if he cool down already, then he will not combine with oxygen because copper is a low reactivity metal. If you heat it, it will react with oxygen. But if you don't heat it, it won't react with oxygen. So from here, we say that is to prevent air from entering, because oxygen in air will react with hot copper to form back copper 2 oxide. Okay, and lastly, guys, actually this experiment, how do we end this experiment? Do we just hit and then we wait for 10 minutes and then we call it a day? No. Actually, this experiment in real life, you need to actually repeat hit, cool, measure mass. Then you hit, cool, and measure mass. If the mass is still changing, you are not done. So you have to hit, cool, measure mass. Still changing? Okay, changing is like what? Like the mass you see here. How do we know that this 147.95 is like the actual mass? Wouldn't be like 14148? Why not 149? Why not 1150? It's based on this number. If you hit cool and then he weigh, hit cool and weigh, if the mass still changing, like say maybe now you get 151.15. After you hit, you cool it, you measure, maybe you get 152. It means the experiment is not done. You hit cool and measure again, maybe 153. Still changing, not done. You're gonna actually repeat until you maybe 153. Then next time you repeat 153. Next time you repeat 153. Next time you repeat 153. If you keep repeating but the mass is not changing anymore, that is the end of the experiment. Okay. So of course you have to say that to ensure all copper 2 oxide are completely changed to copper. Okay. Do we only write the copper 2 when it's combined with oxygen? Yes, if it's copper itself, it's just copper. But when it's copper combined with oxygen, it's called copper 2 oxide because the 2 is the charge. Copper 2 oxide is because Cu right now is 2 plus. But when Cu is alone, it's no charge. So no need the 2. Okay, that day you do magnesium experiment in school, you get not accurate because no time. It's okay one because the one you all do in school, it's just for fun. Really just for fun one. Just to let you all experience what is the experiment. Teacher don't really care whether you get accurate or inaccurate results. Same thing goes for Amali, guys. Even if your Amali result is wrong, actually is fine one. Okay, because maybe got human error, maybe got apparatus error, got like chemical error, it's fine one. No time. Teacher said got the result never accurate 1-to-1 because film come out. Yeah, if you open close, the film always fly out one. Okay, teacher, I did magnesium 1 and wrote something wrong, so it turned into Mg 580 O. So your ratio between Mg and O is 580 to 1. Interesting. What an interesting number you get, 14 gram of oxygen. 14 gram oxygen. Good job. Okay, guys, so after copper oxide, let's do one question of magnesium oxide. Okay, you flip a bit. Okay, maybe I do page number 23. Listen. 23, Okay, so this is the magnesium ribbon that you all did in school. I believe most of you guys did this in school. If your school never do this experiment, a bit sad. Okay, this one is like a whole Malaysia school we're going to do one. Okay. What is the meaning of empirical formula again, guys? This is the second time you're writing this definition. It's a chemical formula that shows the simplest whole number ratio of each atom of each element in the compound. Okay, so this one you can actually write this one So try to force yourself to write again, okay? Oh guys, be hungry. Let me drink some water. Okay, why must the lid open occasionally during heating? So guys, occasionally, periodically is the same meaning. Means you open once in a while. Okay, so you open for what? To let the oxygen react with magnesium. If not, you close it all the time. Oxygen not enough. Okay, so we're gonna say that to allow oxygen to enter and react with magnesium. But you open, you close it back. Why? You will see after opening, the lid is closed immediately because just how someone you all say, the white film will fly away. But guys, don't say fly away. You have to say that to ensure white film does not escape from the crucible. Okay. Name another metal which its empirical formula is of its metal oxide can be determined using the same setup. So guys, means in this setup, what's the theory right here? This setup right here is magnesium direct heating with oxygen becomes MgO, right? So this is available because magnesium is a reactive metal. And if you do this to copper, can, but very slow. You'll be waiting like few hours, only can become CuO. So this method not suitable for Cu because copper is a low reactivity metal. So they ask you which metal can use the same setup. I'm gonna look for metals that are almost the same reactivity. So what is metal that are almost the same reactivity? We can go with aluminium. Okay, we can go with lead. Okay, go with calcium. These are fine. But potassium and sodium cannot. I see Isaac say it is potassium. Potassium, sodium cannot because those are explosive metal. You hit, you get explosion. Okay, so guys, zinc, calcium, lead, okay, aluminium. Then school closed down. Wait, no, really, okay. Enter chemistry science stream. The only aim is to burn down the school. Okay. Okay, then explain why empirical formula of copper oxide cannot be used the same setup. As I said, this reaction is a direct heating with oxygen. If your metal is low reactivity, cannot. Okay, so we say that this is copper is less reactive and does not combine with oxygen easily. Okay. And then guys, again, mass given, okay, with the lead, crucible and lead and magnesium, crucible lead, magnesium oxide. So if I want to find, if I were to find magnesium, I will look for 2 minus 1. If I look for oxygen, I will 3 minus 2. Okay, so calculate mass of magnesium and oxygen. So this will be 2 minus 1. This will be 3 minus 2. Okay, so you put in the calculation, put in the mass, okay. How to calculate number of mole? Divide the molar mass law. So molar mass is it given? Why he never give you, but never mind, I give you, okay. So magnesium is 24, oxygen is 16, okay. Guys, this one is always provided in question, so don't worry about this. Okay, but guys, the table is not provided. You need to draw your own table. Let me show you the exam paper in the beginning, guys. I show you test paper in the beginning, right? Do you see? Determine empirical formula of magnesium oxide like this, 3 mark. You need to draw your own table. You need to label element, number of mole, ratio, simplest ratio, this and that. Okay, so see. This one not provided. You need to draw this out and label out yourself. Okay, so if you do the calculation, okay, 2.4 over 24, 1.6 over 16. Okay, then of course, same number, same ratio, same simplest ratio, and your magnesium oxide empirical formula, you will say it's MgO. Okay. Do we need to write ratio of mole and simplest ratio of whole simpler, or you mean both of these? Means you have to write both? Yes. Because not all the time is 1:1. Maybe sometimes you're gonna get like 0.2 to 0.4. Okay. Then the ratio here will be taking like 0.2 divide 0.2, and then here is 0.4 divide 0.2. Here you get 1, here you get 2, then you get 1 and 2. Okay. Or maybe you're gonna get something like decimal place. Maybe you get like 0.2 over okay, maybe something like 0.3 over 0.2. This one is like 1.5. And then this one is 0.2 over 0.2. This one is like 1. Then if you get like decimal place, you have to like multiply the whole thing by 2. So this one whole thing by 2, you get 3 and 2. Like that. So you need 5 rows. 5 rows will be standard. Okay, because not all the time you get like perfect number like this. Sometimes you might get decimal place. So you need to like ratio. If whole number, then you can take directly. If decimal place, you have to do something to it. Okay, if the ratio is the same, can you skip the simplest whole number? You're really cannot do one more extra writing one, no? Finding all the way to reduce your thing to write. Write everything. Okay, if have decimal, how many do we take? Usually decimals here, you wouldn't get like very complicated decimals, but even if you get complicated decimals, you take two. Two decimal place is fine. Minimum two. Let's say if you get like 0.3556 0.36 or something like that. Take two decimal place is fine. Okay, and what is the use of magnesium oxide? Guys, this one a bit out of syllabus because this one actually is form 5 in our chapter 5. Okay, but never mind, guys, this is give you an idea first. Magnesium oxide is using in your medicine. Antacid, okay, which is actually the medicine for gastric. Okay, if anyone here having gastric, you know Gaviscon. Gaviscon is the brand that sell you the for the gastric pain one. Okay, so their inside got this magnesium oxide. Because magnesium oxide is actually an alkaline, it can neutralize your gastric juice. Always got advertisement. Yeah, Gaviscon. I think that the gray color fireman. Okay, go to your stomach and then spray the gray color liquid. Okay, can so guys, I did one question for copper oxide. I did one question for magnesium oxide. Hopefully it's fine. The rest you all try. Okay, so the last thing to do is to give you questions a bit weird. Something like page number 26. Okay, page number 26. Why got Panadol? Yes, guys, your favorite. Sorry, how is this a favorite? sorry. Okay. So guys, you see, you see Panadol. They say paracetamol is commonly used medicine that can help to treat pain and reduce fever. It's typically used to relieve mild or moderate pain such as headache, toothache, sprains, reduce fever caused by illness such as cold and flu. He can take 500 milligram tablet 4 times a day in 24 hours. You must wait at least 4 hours between doses. Do not take more than 8 tablets in 24 hours. Guys, you read the whole sentence. Do you feel a bit useless? Do you feel like it's a bit nonsense? Like, teacher, okay, then, okay, all this information then, so you see, what is the chemical formula of paracetamol? Guys, don't get confused, don't get scared by the words, by the diagram. Just based on the diagram given, do whatever you know. What is chemical formula? Literally, what's chemical formula? It's like MgO, CuO, like C6H12O6. All these are chemical formula. So how do you find chemical formula? Count the element in the diagram. So what do you do? See, how many C? Okay, let me do something like this. How many carbon? Okay, what elements we have? We got carbon, we got hydrogen, we got oxygen, we got nitrogen. Okay, now this is what I see. I got C, got N, got H, got O. Okay, then I can go and count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so C8. Okay, how many H? 3, 4, 5, 6, 7, 8, 9. So 9H. How many O? 1, 2. So 2. How many N? 1. No more. Okay, so guys, you see the answer. C8H9. O2N, or the answer is NO2. Guys, the sequence doesn't matter. The sequence don't matter for now. But I will strongly suggest you put the C and H first. Okay, the C and H first. The NO, which one comes first doesn't matter. Okay, now guys, one more. Just by counting how many C, how many H, how many O. Okay. What is the relative molecular mass? Guys, what is relative molecular mass? Is the total of your atomic mass. So what you're going to do? By taking your formula, substitute the H, the C, the O, the N, the atomic mass, go in to the chemical formula, and you can get your molecular mass. So you see like C8, so 8 times 2, and 8 times 12 plus 9 times 1 plus 14 plus 16 times 2. Okay, so you do the maths, huh? So you get 32, 46, 55, 151. Okay. Oh, can I? And then they ask you, what is the molar mass of paracetamol? Guys, what's molar mass? Molar mass is what we did in the formula. Usually it's the number of mole equals to mass over molar mass, right? But if you remember molar mass, do you need to memorize? No need, right? Molar mass is literally taking all this based on the chemical formula, which is be like, teacher, isn't it this? This is what we did, right? Molar mass is you take every atomic mass, substitute into your molecular formula, then you find the molecular mass. Oh. Guys, the answer is yes. This question is telling you molar mass and molecular mass is actually the same number, but with a unit. So 151 gram per mole. Molar mass got unit one, guys. Yeah, so molecular mass no unit, but molar mass got unit. Because guys, actually it doesn't matter. The number is the same. We use it in formula, right? We use it in formula, so it has unit provided. Okay. Next one, calculate number of paracetamol molecule. Guys, comes to our play on formulas. If they want to find number of molecule, which formula is actually the suitable one? Which formula suitable to use to calculate number of molecule? Okay, guys, do you think this one is suitable? I will say no. Okay, but what else? What formula we have? Number of mole equals to volume over molar volume. Not suitable also because nothing to do with volume here. Lastly, we got number of mole equals to number of particles over Avogadro constant. Remember that? That is why the question gives you Na equals to 6.02 times 10 to the power 23. That's the Avogadro constant. Correct? So with this, you are looking for the particle. Why? Because particle includes atom, ion, molecule. Okay now, atom, ion, molecule. When you're looking for molecule, means you're looking for number of particles. Okay, but guys, if you think about it, what is given? Do you see question give me 500 milligram? That's 500. 500 milligram it's actually the unit for mass, right? But that's not the usual unit we use. What's the usual unit we use in calculation? For mass, we usually use gram. So 500 milligram, can you convert to gram first? Anyone remember? What do you do? Milligram to gram. Anyone? 5. Very good. Multiply 100. Like millimeter to meter. Okay, now. Okay, so milligram to gram. So it'll be 100 plus, sorry. 1,000 to gram. 1,000. Why I say 100? 1,000. So you divide 1,000. Okay. Not 100, 1,000. Like millimeter to meter is 1,000. Why I say 100? Millimeter to meter is 100. Then I cannot use this example. This milligram to gram. Okay, so guys, just in case you forgot, so 1 gram equals to 1,000 milligram. 1,000. Oh yeah, 1,000. Shit, guys, my unit conversion. So 1,000 was correct lah. Hiya, GG man. My unit conversion. I even forgot millimeter to meter is 1,000. Oh yeah. Thanks for Thanks for clearing my thoughts. Okay. Morning blur brain. Guys, cannot lah. Long time never wake up at 10 already. Okay, so with the mass given, I want to calculate number of molecule, correct? So with mass given, I cannot use this formula first. Instead, I'm gonna use with the mass formula first. Remember, guys? I always tell you, you start with the value provided. So if you are provided with mass, I use the mass formula. So what do we do? Mass is 0.5, and then the molar mass is 151. So my step one will be number of mole equals to mass over molar mass. So it'll be 0.5 over 151. Okay, so you press the calculator, 0.5 over 151. So you get what? Very small number, 0.0033. Okay, take two, fine. Take two, significant figure is fine. Then this one is mole. Okay, but then once you have number of mole, can you convert to particles? Okay, so I'm going to put in the second formula, number of particles over Avogadro constant. Well, here is 0.0033. Here is the Na is 6.02 times 10 to the power of 23. So this is not number given by question. So to find number of particles, you're going to multiply. So multiply 6.02 times 10 to the power of 23. So you're going to get 1.99 times 10. How many? 21. Is it? You all press the calculator, guys. See whether correct or not. Okay, because I don't have a scientific calculator. Correct. So 1.99 times 10 to the power of 21. Okay, good job. Okay, then of course this. Okay, guys, before you do anything, the actual unit is particles. Okay, but to convert particles to your specific type of particles, you need to do some multiplication. So how do I convert to molecule? You're gonna look at the molecule. So guys, this whole thing is considered as one molecule. So you're gonna multiply 1. You're gonna get 1.99 times 10 to the power of 21 molecules. Okay. But when do we need to multiply different numbers? If they want you to calculate number of atoms, then you're gonna multiply number of atoms. How you gonna find number of atoms? You count. So you got C8, H9. Okay, we got eight carbon atom, 9 hydrogen atom, 1 nitrogen atom, 2 oxygen atom. So you get 8 plus 9 plus 1, 18, 20 atoms. Then here you must multiply 20. If they're looking for atoms, you have to take your particles, multiply 20. Okay, but of course, here no need lah. So here, just looking for molecule, just multiply 1. So actually, molecule always multiply 1. Okay, calculate number of molecule, always multiply 1. Okay, and then calculate maximum number of mole of paracetamol can be taken by an adult. Okay, so what is the number of mole? Okay, so here, so he say is 4 times a day. They say take 2 500 milligram tablet. So means each tablet there is 0.5 gram. Just now we converted already. But each time you can take 2. So means each time you take 0.5 times 2, which is 1 gram. Okay, each dose is 1 gram. But 4 times a day. So means times 4. So ultimately, each day, what's the maximum mass you can eat? Is 4 gram. Okay, now, but they want number of mole. So 4 gram divide the 151. Okay, so we can get something like this. You can do like number of mole equals to 4 gram over 151 also can. So you get the same answer lah. So 4 over 151. You're going to get 0.0265 mole. Like this way also can. Okay, or you just straight away take the number of mole that you calculated, you times 8, because it's 8 times based on the 0.5. Okay, either way of this. Okay, and determine the mass of 0.15 mole of paracetamol. So now they give you number of mole, they ask you to backward calculate the mass. Okay, so to calculate mass, use number of mole equals to mass over molar mass. So number of moles, 0.15. Molar mass, 151. How to find mass of paracetamol? You do the maths. So 151 times 0.15. 22.65. Right. Okay, guys. All good, Can, Okay, so guys, of course, the rest of the question is very similar, lah. You give us some weird diagram. Oh, look at this. Oh, sure. Guys, don't skip. Just count later. Okay? So treat everything as like we done before, okay? Don't get nervous in exam, okay? And now, of course, we have many, many type of questions. Okay, let's say we see like question number 8A. This one is page number 29. This is like advanced version of what we did in empirical formula, lah. Instead of using MgO and CuO, we give you some weird chemical like quinine. What is this? I don't know. But they say it used to treat malaria. Then they say got percentage of carbon, percentage of hydrogen, nitrogen, and the rest is oxygen. So what you're gonna do? Use the percentage as your mass directly is fine. Okay. But they say the rest is oxygen. So oxygen, no percentage given. So what you're gonna do? You're gonna actually take your 100%, because maximum percentage is 100. Take 100 minus all the percentage, the leftover is your oxygen. Okay now. Then if you have this as your mass, you see the mass like this, then you do number of mole. You take mass over molar mass, mass over molar mass, mass over molar mass, mass over molar mass. Then you calculated the number of mole, then you can do ratio as usual lah. Okay now. So let's say, guys, why I want to go through this question now, because this one you can do it yourself later. Okay. So let's say right now my final answer is C10H12NO. Okay. This is the empirical formula of quinine. Okay. So of course, if this one okay, you can do later. You can do your own calculation. This one okay. I skip first. What I want to do is something like this. They found you you calculated your empirical formula yourself. The next question after this is to actually give you the molecular mass, which is this whole thing. Total up is 324. What is the molecular formula of quinine? It means that you're not supposed to use this and then substitute number, you get 324. It's supposed to be the actual formula, because is this actual formula? Is empirical formula the actual formula? Not sure yet. Because we only know this is a simplest whole number ratio. So if this is a simplest whole number ratio, what you have to do is you need to find the actual multiplication to convert it back to molecular formula. What's the meaning of that? Okay, let's say if I give you an idea, let's say if I have one chemical example C6H12O6. This is glucose. This is called molecular formula. But if you simplify it, become empirical formula, you can divide the whole thing by 6, correct? It becomes CH2O. But if you want to convert back to molecular formula, you're going to multiply back 6. Is that correct? So the question is it always divide 6 and multiply 6? We're not sure. So you first need to find the multiplication, the relationship between your empirical formula and your molecular formula for this chemical. So what you're going to do for this kind of question, you have to use the general formula, which is actually called empirical formula. How you convert to molecular formula? You need to multiply an unknown number, only can turn back to molecular formula. So this is the simple idea, the relationship between molecular formula and empirical formula. So what you're going to do, you're going to take your empirical formula, C10H12NO, bracket N equals to 324. Means you total up the whole thing with the N, That is the whole mass of your chemical, right? So equal to the 324 lah. And I say take the molecular mass equal to the whole thing. So what you're going to do? Substitute your C equals to 12, O equals 16, H equals to 1, N equals to 14. Put the number in, find the N. So if you put the number in, it'll be like 12 times 10 plus H times 12 plus 14 plus 16. Okay, this whole thing multiply N equals to 324. Okay, so you do the maths lah. So you're gonna get like 14 plus 16 plus 12 plus 150. So you're gonna get 162 here. So 162N equals to 324. So your N is equal to 324 divide 162. So you're gonna get 2. So the multiplication is 2. But what is the molecular formula? So you're gonna find out like this. So molecular formula is equal to C10H12NO bracket 2, which is C20H24N2O2. Okay. So even though you don't know what exactly is this, what is a quinine, don't know, but all the steps is something you learned before. Okay, the empirical formula step you learned before, the molecular formula step is also you learned before, just that we're going to have a complicated or different formula. That's all. Okay now. Okay. So this one is the last thing I want to do lah, to calculate molecular formula. Then of course, guys, there are many questions at the back. Okay, so after this seminar, after today's seminar, we'll upload the answers into the Google Drive. So you try it yourself and then you check the answer. Okay, all good, so guys, hopefully, okay, waking up early in the morning on Sunday will make your hard work worth it. Give me good news, okay, after your first exam. Okay, so guys, if okay, that's all for today. I'll see you all in normal class. For those who in my normal class, thank you guys. Bye. Bye. Bye.